Guys, in this video, I want to talk about the power of complex numbers. Guys, this French mathematician de Moivre actually came up with this theorem where we can see how to take the powers of complex numbers which are expressed in the polar or the trig form. Guys, I want to kind of start with the simple basic example, and then from there we can generalize and see what the de Moivre's theorem actually states. Okay, so guys, we already know if we multiply two complex numbers in the trig form, what happens to the absolute values and what happens to the angles. The absolute values are just simply multiplied and angles are added. So let us say in this case we have two complex numbers which are exactly the same. So let's say I have z1 equals to r cosine of theta plus I sine of theta, and I want to multiply by another complex number which is exactly the same. So let us say z2 is also the same, cosine r cosine theta plus I sine theta. So if they are exactly the same, then if I multiply them, so z1 times z2, since they are the same, and let us call both of them also equal to z. So if since they are the same, we can call them just z. So it is basically doing z square, right? Z times z is just doing z square, and they are the same. So since they are the same, let me not use z1 and z2 because they are the same, so I don't want to confuse any of my students here. So because they are the same, so I'm just writing z twice. Okay, so when I multiply them, z times z is z square, and when I actually multiply the right hand sides, we already know what we have to do. We have already learned how to multiply and divide two complex numbers in the trig form. So what we do is we multiply the absolute value, so r times r is going to be r square, and then we just add the angles. So it's going to be cosine theta plus theta. But what is cosine theta plus theta? Simply 2 theta, and same thing with I sine of 2 theta. So the angles are added when we multiply complex numbers. Similarly, guys, if I try to go z times z times z, which is z to the power 3 or z cubes, what's going to happen? You can start with z square. You can break it down as z square times z. You already have z square, which is r square, and then cosine 2 theta plus I sine 2 theta. And then you can multiply by z, which we already know is just simply r times cosine theta plus I sine theta, right? Guys, if I multiply these, again using the properties of multiplication, multiplying any two complex numbers, what do we do again? Guys, we multiply the absolute values. R square times r is going to be r cube. And then what do we do with the angles? We just add the angles. So it's going to be cosine 2 theta plus theta, which is just simply 3 theta, and plus I, same thing, sine of 2 theta plus theta is just 3 theta. So guys, you can already see what is happening here. When we squared it, z square, what happened? We get a square here, and there's a 2 and a 2 here. When we cube it, we get a 3 here and 3 and 3 here. Similarly, guys, we can generalize this, and if we go up to z to the power n, that means we're multiplying this complex number n times. So if we do that, then we can already see from this pattern here that it's going to be r to the power n, right? Based on this pattern that you can see here. And then here is going to be, you're adding the angles n times. So your theta plus theta n times, it's going to be cosine of n theta, and then plus I sine of, again, n theta. And guys, this is called the de Moivre's theorem. De Moivre was a French mathematician who kind of realized this and made this generalization. Guys, this is a very useful result. Once we establish this, and we have already established it, now we are going to look at some examples, and when we start doing these examples, then you will see why this is a very useful result. It kind of opens up a lot of new opportunities and a lot of new things that one can do in the complex number system, and then using the trig functions kind of gives way to more and more things that one can do here. Okay, so guys, this is what the de Moivre's theorem is, and we are going to use this theorem for different examples. In my next video, I'm going to start doing some of these examples. Guys, please make note of this. You already know how to multiply. We already know how to divide complex numbers in the trig form, as well as we should know how to multiply and divide them in their standard form, a plus ib form, where a and b are like real numbers, real part and the imaginary parts. Guys, I will see you in the next video with examples. Till then, take